In this video, I want to go back and define limits and continuity in some amount of detail. Up to this point, we've been a little bit informal about what these terms actually mean. And what I want to do is to give you the actual definition of them so that we can use that to solve problems going forward. All right, so for f to have a limit at a real number c, so to say the limit as x approaches c of f of x, in order for that to exist, we need three conditions. So we need the limit as x approaches c from the negative side, that limit has to exist. The limit from the positive side has to exist, and those two limits have to be equal. We've been seeing that over and over again, so hopefully that doesn't come as a surprise to anybody that, if we've got a function that looks like this, and this function comes and goes sort of like that, then this has a left-hand limit and a right-hand limit, but they're not the same. So that means that the limit doesn't exist. What we would need is for it to look like this. So our left-hand side of the function looks like that, and our right-hand side of the function looks like this, and they both meet at that same spot. That's what it means to have a limit, even if we have an open circle here, if the point isn't defined here. All right, that's going to be an important part of the definition for continuity. So we're going to say that f, a function, is continuous at a real number c. Once again, we have three conditions. We need the limit to exist, just like we defined here. We need the value of f to exist, and those two values have to be equal. All right, so let's see three different kinds of functions that fail to be continuous. So, for instance, this first example, so this function isn't continuous at c because there's no limit there. Okay, so our informal definition that you can draw the curve with one swoop of your pencil, we definitely, no matter what value we would have in here, that's not going to work. All right, so that's our case one. Our case two is this function right here. So even though there is a limit, so this matches our first definition, but it doesn't match our second definition because the function isn't defined here. We've got an open circle. So when we're drawing this function, we have to skip over it. So I'm picking up my pencil to do that. So this is a function that fails condition 2. And condition 3, is it possible for the limit to exist and for the value to exist, but they're not equal? Well, in that case, we've got a function that looks like this. So we've got an open circle there, but the function is defined at this point down here. All right, so this is an example of how f is not continuous at c because not only do we have to skip over the point here, but we have to go back to fill in that point. So this gives you an idea of how all three of these points are important ones. And so in order to have a continuous function, it would look something like this. And if it weren't defined at a point, you would need to actually fill that in. But when it's filled in and you're looking at it like in an IXL assignment, the function actually looks like this because the function is something that you can draw without a closed circle in the middle of it. Okay, so this is a definition of continuity that we're going to need for some problems that we're heading into doing right now. So hopefully that made some sense to you.